introduce myself. I'm Rajat Sharma. I'm a senior software engineer for IBM, and I'm also a maintainer for this open source product Feilong. So Feilong comes from a Chinese word means flying dragon, and like these products were designed by people in China to make this EVM interaction easy. So we know that nowadays people have very limited these skills. People don't know how to interact with 3270 screens, green screens. So to make it easy, we developed a module which we use to with REST APIs, we'll connect with EVM and do this guest lifecycle. So what we do with EVM is provide a RESTful APIs which we can do all kind of operations on EVM. You can create VM. First, for that you need a Linux VM. On top of that, you can install this Feilong product, and then it can perform all lifecycle operations. And today I'll show a small demo. So I'm from IBM, and we have a product which uses this Feilong product with our product, and we kind of provide our infrastructure as a service with like underlying lane is OpenStack. Then we integrate with Feilong, and we deploy like VMs and VM lifecycle. So this is the product homepage as this Feilong repo, and this build Feilong is you can directly install Feilong executables and deploy in your environment. And this is the main this mailing listing, and we have like meetings for this open source around every first Wednesday of every month. So we have kind of 96, when I prepared this slides, we had 96 Git forks, 52 active contributors, and most of the contributions are coming from IBM, but we have strong contributors from colleges and SUDA. So this is the architecture. So this big yellow box is Feilong, and rest is like the integrated tools. We have a RESTful API layer, transition layer, and one SMCLI which we call ZHCP. So there is something called SMAPI, which is like APIs that we have to that we use to interact with ZVM directly. But these are very complex, so you can get required some skills, and it's a time-consuming process. So we wrote a C wrapper on top of SMAPI, and which we use with the SMCLI commands. These commands are internally called by this RESTful API layers also. So what we do in REST API layer, we kind of do the validations for the APIs, whatever API or whatever the operation we are trying to do, will it work in this environment or not? Is it all the parameters are correct? Or the API that we are trying to call will work or not? So to deploy the full scale infrastructure, you need a ZVM LPAR. On that, you need Linux distribution. We support kind of all major distributions: SUSE, Red Hat, Ubuntu, and on top of that, you can deploy this Feilong. And we also have IUCB protocol. So what IUCB does is like it's a inter-utility like protocol. But so you are deploying the ZVM guest, so you don't want to export the credentials to the outer world, but you need to run some commands from your management node or from other VMs. So with IUCB, you can directly communicate between the VM virtual machines or your base layer of the LPAR. Now this slide is to indicate how Feilong works with other open source projects. So we can integrate it with Terraform, OpenStack. So in our product, we integrated with OpenStack. So these two modules like OpenStack Nova and Open, these are like compute and networking layer. So we can make the Feilong talk with OpenStack Nova, and when you do any kind of guest operation, all the requests will come to Nova. Nova will filter out or do basic checking, and then it will hand it over to Feilong. Feilong will create a proper syntax which will at the end execute this SNAPy API and do basic validation. Okay, so for why we need Feilong first of all. So for, as I mentioned earlier also, so when you have to deploy guest or distribute your existing helper into a smaller chunk of helpers, you need skills. You need the green screen skills, 3706 terminal skills, and that is very hard to find nowadays. And most of the customers or anybody who is using the mainframe, they need the simplification of the mainframe system. So with this Feilong, what we can do is you can set up a separate LPAR that will act as your calling system, and that will then manage your entire Z mainframe. I think we can create around 84 LPARs from one system. Okay, so this the Feilong's role in infrastructure. So as I said, it's act as a bridge between your mainframe and REST API. So when we are managing our like infrastructure, if we have to do it manually, then it take a lot of process. So if you have to create a virtual machine from the REST API itself, then it take around roughly 3 to 4 minutes with end-to-end disk creation, network allocation. If you are trying to attach some storage, then that as well. So it take around 3 to 4 minutes to complete the entire VM creation flow. But if we have to do it manually, then it takes like around 10 to 15 minutes. Or like you have to do everything manually. You have to create all the encryption files, cloud files, everything. So it saves a lot of time. And like being this open source, so it can plug into any number of other, like we can, as I mentioned, Terraform or OpenStack. We can, so we have in this year we have the summer mentorship. So in that, what we had is a mentorship project where we created a UI also. So with that UI, you can directly install Feilong and call the API. So it works really well with OpenStack. So OpenStack at the backend need a hypervisor to run, and with what Feilong does is provide a Z hypervisor to your OpenStack, and you need to do some modifications to add ZVM hypervisor layer in OpenStack worklist. After that, you can run any operation that we can do on x86 machine, we can run on this S390 as well. Yeah, so for the security purpose, let's say you don't want to expose the entire ZVM the mainframe to the user, so you can create self-service user itself. So those self-service user can interact with Feilong and then do end-to-end lifecycle operations. So I think I will talk about this, and this is the so we conduct a internship program, like for 6 month internship program for this open source, and we had two interns this year. One is Divish and one was Paras. So we contributed in two projects with this. So what Divish's product was, it was so since we started this way back in 2017 or 18 product, so the entire product was in Launchpad, all the bugs, codes base. So now, since we moved to GitHub, so we have to check if anything is like not cleaned up properly, what is accurate, also what the wastage is hidden end-to-end lifecycle flow, and then check whatever bugs are valid, what are not, and whatever need to be migrated to GitHub, he migrated those, and some of them he fixed as well. So this was the challenge. Around 98 bugs was on Launchpad, and only 90 was in GitHub. So we migrated most of them and fixed a few as well. So the second mentorship program was ZLMA. So ZLMA is provides a UI on top of Feilong. So this is now in itself open mainframe product, I think in incubator. So with this you can install it on top of Feilong, and you can see a full-fledged UI, and you don't need to interact directly with CLI or REST APIs as well. So this is our mentorship program. With 2024, we instituted one more project which build like give executable build RPM, and this year we did this give blobs to bug list and ZVM this Zelma. So I have a small demo. I'll show how. So first I'll show how with direct API calls is we create guest, and then I'll show a small demo of how in IBM we use it with our cloud infrastructure center. So this is our 32970 screen. So this GVM SDK. So the big screen which is the middle layer, that was our SDK server, and it runs this process. So I'll run a watch on this to see internally what all function is performing. So I have started a guest deploy. So all these operation it will do, it will create a disk first. It will format the disk, do unpack or pack and pack of the disk, and then deploy the image in it.
Maybe it's seen on the screen.
So here I'm starting a guest deploy from the REST API. See, all this the operation it's doing, it's internally calling SMCLI, formatting the disk, and it did disk unpack in the previous step. Now let's see, it will show one instance here. So this is ICAC UI. So here what it will So for this I'll show two functions. One is VM deploy and one is live guest relocate from one host to another from via ICAC UI. Here you have to select OS or like basic template that you want to deploy. In this I'm using two processors, 4 GB of memory and 10 GB disk space. So it's doing the same things that with the rest it had shown. Disk format and unpack. This is the, so what it does in this unpack is whatever OS related files we had stored in the image, we transfer it from our compute node to the disk. And the disk has like two owners. One is the VM itself, and second is the compute node from we are filing these commands. So this is the VM that we deployed from ICAC. Now I'm going to show one LGR. So what we do is like LGR is live guest relocate. So let's say you have two VM alphas and you want to move your guest from one to another without any downtime. So for that, both of your alphas should be in SSI cluster. So with LGR, you can migrate the guest directly. So my this VM SSI, this is my one alpha, and I'm going to move from this 100.51 to the second. cp command to check where it is. So this right now this instance is in 46018. And with the single click of button, so I'm moving it to a say tool helper. It takes around 1 or 2 minutes to migrate. Now if you see, it is moved to from 4608 host to 4607. Yeah, so that's it. That's what I had to present. Any questions?